The figure plots the y position of particle as a function of time. Okay, comes up, goes down, seems reasonable. At t equals 3, right there. Second, which of the following statements is not true? Okay, so position, velocity. So basically the position, that's just going to be position. The speed or velocity will be the derivative of position with respect to time. This is calculus. And acceleration will be the second derivative of x with respect to time. So for here, this is the first derivative with respect to time is going to be slope. This will be concavity. And we'll talk about that a little bit when we get to it. Whoop. So first one position of y equals 0. Yep. You just look at the graph. And at this position, it is at 0. So y equals 0. This is y. Boom. 0. Okay? So that's true, which means it's not false. The velocity, probably write a little t there. Velocity, now it's going to be the derivative of x with respect to time. I say x, but I really mean y. Just position with respect to time. So that's going to be the slope. In this case, we see it's negative. So dy dt. I know, my y's even look like x's, which make everything even more confusing. Less than 0, negative slope. So this will be not 0. It'll be specifically less than 0, which makes it false, i.e. not true. The acceleration acceleration with respect to y equals 0.3. So this is going to be true. And one way to see this, so concavity, kind of like this. This is just a random graph that I drew. And the way I visually tell concavity is if the position holds water or not. So if you dumped a bunch of water right here, it would fall down that way, which would make it negative concavity, which would be implying acceleration is less than 0. But over here, if we dumped a bunch of water, it would fill up the bottom of the graph. Therefore, that would be positive concavity, which would imply positive acceleration. And right in the middle here, we would have, since we have negative acceleration here, positive acceleration here, somewhere in between, acceleration will probably equal 0. That is called an inflection point. So that's one way of looking at concavity and acceleration. So for this point here, though, I'm going to look at it slightly differently. So I'm going to say that this graph might be y equals negative, I'm going to say m for slope, t. Y equals negative mt. That's kind of just the, okay, plus b. That would be an equation for the line at that point if we extended that part of the graph out. Because it looks linear. We're going to assume it's linear and it's going straight. Well, we take the derivative of that with respect to time, dy dt. The b goes away, and we're left with negative m. That's the slope. And so negative m, where m is assumed to be a positive number, that's one of the reasons we can see that this velocity does not equal 0, because if we know it's negative 0. But then if we take the derivative of y again, this m is a constant, and that equals 0. So acceleration will equal 0. So that's one way you can see that this is also true. So true, true, and false. I know it feels kind of like an easy problem, but it's really important to have a strong understanding of what's going on there, because you don't have a lot of time to do this in-depth reasoning when you're, doing during an evaluated session, during a test, if you will. So you really have to have a good understanding of it before you get to the test. That way you can quickly do it correctly. And you don't want to miss this kind of problem too, because it's easy, which makes it more important that you can get it right quickly. If you get this wrong, then you're going to have to spend more time getting a more difficult problem right. So the easy problems are very important. Okay. At which of the following times is the acceleration less than 0? Okay, so this is going to be concavity. So this means at which point is there going to be a negative concavity, which, as I phrased up here, means it won't be able to hold water. If you pour water on it from above, it won't hold it. So we have 1 times 1 right here. Yep, that's going to be negative concavity because you poured water on it, not going to work. So that's going to be true. 3.5. That looks like it's probably a positive. This is probably actually linear at that point. So concavity is going to be probably 0, which means that 0 is not less than 0. So this one will probably not be correct. And it might actually be curving upward at that point, which would make it positive, but it's not negative. And then we'll look at 5.5. So this would be a sort of, we could write the equation as y equals -1, derivative of y with respect to time equals 0, derivative of 0, it will still be 0, and so this is going to be 0. This is probably 0, that's definitely most likely 0, and so the B and C are wrong answers. So the acceleration will only be negative, we'll have negative concavity at t equals 1 second. Okay, which of the following times is the velocity less than 0? Okay, so we get a different color because I have so much going on. Did I get green? Is that a good contrast? It's a good contrast. So t equals 5 seconds. So that's going to be velocity equals 0. We already said that for this equation we can say it y equals -1 because it looks about that. Probably not exactly, but close. Derivative of that will be 0. So derivative of -1, 0. So that's not going to work because 0 equals 0. It does not less than 0. T equals 2 seconds. So the slope here is downward. So derivative of that with respect to time will be negative. So that's going to be true. This one will be a correct answer. T equals 0.5 seconds right here. Look at the slope here. The slope will be positive, which will mean that it will have a positive speed, a positive velocity. Positive is definitely not negative, therefore it will be the wrong answer. So B, t equals 2 seconds, will be the answer here. So this is kind of just a basic introduction to kinematic equations and the concepts behind them. And this is really important to have an idea here of that position. Well, okay, position basically equals position. We've been pretty strong at that since like 6th grade. Speed can be represented as derivative of position with respect to time. That's why you see position is measured in meters, slope measured in meters per second, derivative with respect to time, and acceleration will be meters per second squared, the second derivative with respect to time. So slope will be dx dt, which will be represent velocity. Second derivative, which is related to concavity, will be acceleration. So hope that helps. I will see you on the next problem.